So last class we started to talk about what an actual radian was. We said when we were looking at a circle, if we took the measure of the radius, and we said the radius was from the center to the edge, and we wrapped the radius around the circumference, a radian was the angle that opened as far as the radius wrapped around the circumference. So this would be 1 radian. And then we also talked about, we knew that a circle had 360 degrees. So if we went halfway around the circle, we only had 180 degrees. And we discovered that 180 degrees was the same thing as pi radians. So what we're going to do today is we're going to look at why we want to use a radian when we're working in calculus. And we're going to figure out how we can calculate what's called a coterminal angle. Because I can take my radian, my terminal side of my radian, I can take that terminal side and I can continue to rotate it around, and I can rotate it around again. I can go negative. So I can get multiple measures when I'm talking about a radian. I can have 1 radian, I could have pi radians, I could have 2 pi radians. If I kept going and I traveled around the circle again, these are my coterminal angles. So they fall in the same place as the circle, but because I'm spinning it around multiple times, so if I go once and then twice, even though I land back in the same spot, that angle would be 300, or it wouldn't be 360 degrees, it would be 720 degrees because I went around twice. I ran around once and got 360 degrees, and then as I traveled around again, I got 720 degrees. So as I continue to spin my terminal side around the circle, I'm getting all these what are called coterminal angles, angles that look like if I stop moving it, they're in the same place. But because I actually spun the terminal side around and around multiple times, the angle measure is actually a lot bigger. I can do the same thing with negative angles. So maybe I went this way and I kept going and I measured backwards and got a negative angle. So coterminal angles are just angles that show up or are on the same place of the circle but have different angle measures. So let's write that down. When we're talking about a coterminal angle, it's an angle that share the same initial side and terminal sides, but they have different measures. So share the same initial side and terminal side. So they look the same, but one of them was wrapped around multiple times, so they have different measures. So let's look a little bit more specifically at measuring a coterminal angle, calculating a coterminal angle. And when we do this, we can do it in degrees or we can do it in radians. We want to start to get used to working in radians because that's what we're going to mainly use in calculus, because a radian allows us to compare a linear measure and an angle measure. So it allows us to work with multiple measures, and it's a little bit more convenient when we're working with calculus, whereas a degree only allows us to measure an angle. So we're going to use degrees because we're comfortable with them right now to kind of get a better feel for radians. But eventually we're going to move completely to radians so that we can start doing more calculus with them. So let's look at an example. So let's find coterminal angles for 90 degrees. So now, first I'm going to draw in my circle. Then I'm going to draw in my x and y axis. And we know that 0 is here, 90 is up at the top, 180, 270, and 360. So I know that my angle that measures 90 degrees has an initial side at 0 and a terminal side at 90. And when I measured that angle, I rotated around counterclockwise 90 degrees, so the first quadrant. So now if I want to find an angle that is coterminal to 90 degrees, I want to take this, and copy and paste it, and I want to actually rotate my terminal side around the circle a full 360 degrees, because remember I have to get back to have the same terminal side, but I need to gain more angle measure, so I spin it around. So in order to show that I did that in a drawing, what I would do is I'm going to say, okay, I traveled along here, and then I kept going. I spun it all the way around until I got back to 90 degrees. So if I'm drawing a coterminal angle, the most important part is showing this kind of curved angle measure here that shows me how many times I traveled around. If I wanted to do it again, if I wanted to add another 360 degrees, I would just keep drawing all the way around my circle. If I wanted to calculate what 90 degrees is coterminal angles are, I'm just going to take my 90 degree measure, and I traveled a full time around the circle, so I traveled around 360 degrees, so I add them together, do 90 plus 360, I get 450 degrees. So 450 and 90 are coterminal angles because they share the same initial side and the same terminal side. The only difference is to get to 450, I had to spin around multiple times. I had to spin around the circle to get to 90, then I had to keep spinning all the way around to get back to 90. I could also find a negative coterminal angle by just subtracting 360 degrees. And when I do that, I'm going to get negative 270 degrees. So we could say negative 270, 450 degrees, and 90 degrees are all coterminal angles. They share the same terminal side. They look the same. The only difference is the squiggly line that's drawn around them. So now, if I wanted to draw a negative coterminal angle, so if I wanted to show negative coterminal angle of negative 270 degrees, the only difference would be that instead of traveling counterclockwise around my circle, I'm going to travel clockwise. So if I'm going to show negative 270, I'm going to start at 0 on my initial side, and I'm going to go backwards. If I went back to, come on, computer. I'm going to go backwards to 90 degrees. That would be negative 270. So what you're going to do today is first you're going to find which quadrant an angle is going to be in. And remember, we know this is quadrant 1, 2, 3, and 4. So you're going to tell me which quadrant they would be in. Then you're going to look at the drawings and find coterminal angles. You're going to tell me what the drawing is saying, what angle measure it is, and then you're going to actually just look at angle measures and add 360 degrees or subtract 360 degrees. So we can also do all of this in radians. So let's look at an example a little bit more in radians. So first example, let's draw 3 pi over 4 radians. So now, if you are still more comfortable working in degrees, that's absolutely okay. You know how to convert these to degrees, so you can go in and convert 3 pi over 4 to degrees to get a better idea. Come on, straight line. But let's take a chance and let's look at and think about it a little bit and find out where 3 pi over 4 would be. So if I wanted to find 3 pi over 4, we know this is 0, 90, 180, 270, and 360. We also know 0 is going to be 0 radians. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. So if I need 3 pi over 4, I need to cut my circle into fourths. So I can see right away that when I cut my circle into halves, I get this 90 degrees. If I need a fourth, I need half of a half, right? Which would be right in the middle here. So when I'm talking about a denominator of 4, I'm really talking about 45 degrees. So my pi over 4, or my 45 degrees, is going to fall right in the middle of 90 degrees. So this is 45 degrees, and it's equivalent to pi over 4, because it's half of pi over 2. So if I wanted 3 pi over 4, I'm going to end up in the second quadrant for 3 pi over 4. Which is going to be 90 plus 45 degrees if I'm working in degrees. But I really just want to show my angle measure of 3 pi over 4. Which is right here. And in order to get to 3 pi over 4, the most important part is I have to show that I only rotated right on the inside of the circle. I only rotated part of the way around. I didn't go around a full time and get back to 3 pi over 4. I only went partially of the part of the way around. So I have to show that I only did that by traveling here. If I wanted to find a coterminal angle, I could say, okay, let's say, example, let's find a positive and a negative coterminal angle for 3 pi over 4. So when I was working with degrees, it was easy for me to say, oh, I know, I'm just going to add 360 to get a positive 1. I'm going to subtract 360 to get a negative 1 because that's my full rotation. It's a little bit trickier when I'm working with radians just because we're not as comfortable with them, we're not as familiar with them. But when I travel all the way around the circle, so if I start at 0 and I go all the way around the circle, I've gone 2 pi radians. 2 pi is the same thing as 360. So if I want to find coterminal angles for 3 pi over 4, anytime I'm working with radians, anytime I want to find coterminal angles for radians, I need to add or subtract 2 pi. So in order to do this calculation, I'm going to take 3 pi over 4, and I'm going to add 2 pi. Now, I know I can't add fractions unless they have common denominators, so I need this denominator to be a 4, which means whatever I do to the denominator, I have to do to the numerator, so I also need to multiply the numerator by 4, which is going to give me 3 pi over 4 plus, now here, 4 times 2 pi is 8 pi over 4. So I have to get common denominators before I multiply. I also can see 8 is twice as many as 4, and I knew I needed twice as many. I needed 2 pi. That fraction is going to simplify to be 2 pi. So I needed 8 pi over 4 in order to find the coterminal angle, and then I just add them together. So if I had 3 pi, I add 8 more pi. Now I have 11 pi's out of 4. So my positive coterminal angle is going to be 11 pi over 4. Positive coterminal angle. Then, if I want to still find my negative coterminal angle, I'm going to do 3 pi over 4 minus 2 pi because I want to go backwards. But again, I know I need common denominators, so I need this to be a 4. I need to multiply my numerator by 4. So I get 3 pi over 4 minus 8 pi over 4, which gives me 3 minus 8, negative 5 pi over 4. So my negative coterminal angle, negative coterminal angle is negative 5 pi over 4. Now, I could find as many coterminal angles as I want because I could just keep adding 2 pi. I could keep subtracting 2 pi. So there are an infinite number of answers for this question, but it's easiest for me to just add 2 pi once or subtract 2 pi once to find a coterminal angle. But I could, if I wanted to, do it multiple times, and all of those times that I was adding 2 pi, I would still be getting coterminal angles. So let's just try one more to make sure we got the hang of this. Let's find a positive and negative coterminal angle for negative pi over 6. So if I need to find a positive and a negative coterminal angle, I need to take negative pi over 6, and I have to add 2 pi. So I need my denominators to be the same. I need this to be a 6, which means I got to multiply the top by a 6. So I get negative pi over 6 plus 12 pi over 6, which gives me 11 pi over 6. So there's my positive coterminal angle. If I want to find my negative coterminal angle, I'm going to subtract 2 pi, right? So then I need it to be the same. I need my denominator to be a 6. So multiply my top by a 6. I get negative pi over 6 minus 12 pi over 6, which gives me negative 13 pi over 6, which would be my negative coterminal angle. So now, if I was given a situation, like maybe I was given negative 13 pi over 6 to begin with, and they asked me to find a positive and a negative coterminal angle. Logan says this is very complicated, but it's okay. Remain calm. And we can do it. So if I was given, for example, let's just look at negative 7 pi over 3. If we want to find a positive and a negative coterminal angle for negative 7 pi over 3, the first thing I'm going to do is I'm going to add my 2 pi, which in this case I need the denominator to be a 3, so I'm going to multiply by 3. And when I do that, I get negative 7 pi over 3 plus 6 pi over 3. And I'm feeling a little uneasy because I'm seeing that negative 7 pi over 3, a negative 7 plus a 6, I already know is going to give me negative pi over 3. But it's okay, right, Logan? We're all going to be okay. Yeah, we can do it. Because even though we added and we were expecting... to get a positive coterminal angle, it's okay that we just got a negative coterminal angle. So we still partially answered our question. We still got a negative coterminal angle. If I need to get a positive one now, I'm just going to keep adding 2 pi to my answer. So I'm going to take my negative pi over 3 because I know that negative pi over 3 is in the same place as negative 7 pi over 3. They're coterminal. I already figured that out. And I'm going to add 2 pi again. So I'm going to make my denominator 3, multiply my numerator by 3. I get negative pi over 3 plus 6 pi over 3. Negative pi plus 6 pi gives me 5 pi over 3. So most of the time you'll be able to just add and subtract in order to get your positives and your negatives, but there's always going to be those weird cases where maybe you just have to add both times, or you might have to subtract both times. It's okay. You don't have to add and subtract. You just need to keep manipulating the angle, keep adding a full rotation around, or keep subtracting a full rotation around until you get one that's positive and you get one that's negative. All right.